Now let's do drug computation. My name, by the way, is Lunalyn, and I am a registered nurse currently assigned in neuroscience department. Since our patient safety depends on our ability to calculate medications correctly in a timely manner, so I'm going to share to you a simple and concise method of accurate drug computation. Number 1, prescription states 200 milligram. Available, you have an ampule of 500 milligram in 4 ml. Question is, how many ml will you administer to the patient? And these are the choices. How to do this? The first step is to find out what volume contains 1 milligram. 1 milligram is 4 ml divided by 500 milligram, or that is 1 over 125. You mean the greatest common factor? I have a separate video about how to find the greatest common factor. The greatest common factor is 4. So 4 divided by 4 is 1. 500 divided by 4 is 125. So a fraction of 1 over 125 ml per milligram, or this is also equivalent, divide this 4 divided by 500, or 1 divided by 125. They are just the same. The answer is 0.008 ml per milligram. So 1 milligram is equivalent to 0.008 ml. The prescription states 200 milligram. We are going to administer 200 milligram. 1 milligram is equivalent, let me just rewrite it, equivalent to 0.008 ml. We are going to administer, this is 1 milligram. We are going to administer 200 milligram. That means just multiply this 200 milligram, multiply it by 0.008, and the answer is 1.6 ml. So the answer is letter C. Another way, the prescription is 200 milligram. The available is 500 milligram in 4 ml. To cancel this milligram, because the question is how many ml. So to cancel this milligram, you have to divide it by milligram also. That is 500 milligram. And the other one is, this 500 milligram is in 4 ml. So you multiply this one. You multiply this 200 times 4, and that is 800. Then this one will be cancelled. You will be left with ml only. And this one, the denominator, 200 has an imaginary denominator of 1. So this is 500. So these 2 zeros, just cancel it out for us to easily calculate this. 8 divided by 5, and the answer is 1.6 ml. Another way of solving this is ratio and proportion. In ratio and proportion, we're looking for this ml prescription. So 200 milligram, and the given is for ml, that is 4 ml over 500 milligram. Now we can solve this by cross multiplication. This one, let our ml be our x. So x 500 equals this one, 4 times 200. 4 times 200, and that is 800. To isolate x in this side, so we have to divide both sides by 500. So we cancel out 500 here, leaving x, and then 800 divided by 500. For easy calculation, just cancel 2 zeros, and then we have 8 divided by 5, and that is 1.6 ml. Number 2, kanamycin 7.5 milligram per kilogram IM every 12 hourly. So this is the order. Available kanamycin 0.35 gram per ml. The question is how many ml will you administer for each dose to a 78.5 kilogram patient. So this is the patient, 78.5 kilogram. And the order says 7.5 milligram per kilogram. That means every kilogram, 7.5 milligram. In other words, we just have to multiply them by 7.5 milligram per kilogram. So this will be cancelled. Now we will have an answer of milligram. 78.5 times 7.5, and that is 588.75. Available 0.5 gram per ml. First, we have to convert this gram to milligram. 1 gram is equivalent to 1,000 milligram. So 0.35 gram is 350 milligram. Now we have 350 milligram per ml, and we are to give 588.75 milligram. Solution number 1. Let X be that ml that we need over 588.75 equals, that solution, we have 1 ml is equivalent to 350 milligram. So we will do the cross multiplication, and that let X is 350X equals 1 ml times 588.75, or that is only 588.75. So to isolate X in this side, we have to divide both by 350. So 350. 588.75 divided by 350, and that is 1.82. So we will just round it off to 1.7. So the answer is 1.7. Another way of solving this is the desired dose divided by the available. The desired dose is 588.75 divided by the available 350 milligram times the volume 1 only. So the answer is 588.75 divided by 350, 1.68 or 1.7. Number 3. Doctors order Nafcillin 500 milligram PO/TID. Available Nafcillin 1 gram tablet. How many tablets will you administer per day? So consider the question per day. The order is TID, that means 3 times a day. So in each dose, 500 milligram, you have available of 1 gram, and 1 gram is equivalent to 1,000 milligram. You only have to give 500 milligram, and that is 500 milligram divided by 1,000 milligram, and you have 0.5 tablet. In each dose, you have to give 0.5. So 3 times a day, so 0.5 times 3, and you will have 1.5 tablets. The answer is letter C. Number 4. The order says morphine 1.4 milligram. Available 10 milligram per ml. How many ml will the nurse administer? Knowing that you only have to give 1.4 milligram, which is less than 10 milligram, and 10 milligram is in 1 ml only, that means we will only administer less than 1 ml. We will eliminate choice A and B because they are more than 1 ml. Dose desired is 1.4 milligram versus the available dose times the volume is only 1. And that is 1.4 divided by 10. There is only 1 0. All we have to do, just move 1 decimal to the left side. So the answer is 0.14, letter C. Another way of solving this is ratio and proportion, or we will do cross multiplication. Let X be that ml that we are looking for, that we are going to administer to the patient, and the desired dose 1.4 milligram. And then that 1.4 milligram is to 10 milligram. 10 milligram is in 1 ml. Now we will do cross multiply, that is 10x equals 1 times 1.4, and that is 1.4. To isolate x here, we have to divide both sides by 10. So 1.4 divided by 10, and that is 0.14. So the answer is 0.14. Number 5. Prescription states 30 milligram per hour. You have a bag containing 250 milligram in 50 ml. At what rate ml per hour do you set the pump? First, we have to identify how many milligram per ml. So we have 250 milligram per 50 ml, and that is 5 milligram per ml. 250 divided by 50, that is 5. So 5 milligram per ml. If we have to administer 30 milligram per hour, that means if we have 5 milligram in every ml, 30 milligram divided by 5 milligram, and that is 6 ml. That means we will only set the pump by 6 ml per hour. Another way of solving this is like this. Desired dose 30, available 250 times the volume 50. So every whole numbers, there is an imaginary number of 1. So numerator to numerator, we will not multiply them. That is 1,500. Denominator to denominator, and that is 250. 1,500 divided by 250, and that is 6. So 6 ml. Another way of solving this again is do the cross multiplication or the ratio and proportion. Let x be that ml that we are going to set the pump, ml per hour, and then 30 milligram, because this is the desired dose, versus the available. 30 milligram is to 250 milligram, milligram to milligram. This is ml to ml. So 50 ml. 50 ml, the available is 50 ml over 250 milligrams. So we have to identify how many ml in 30 milligram. So what we will do is cross multiply. 250x equals 150, 1,500. To isolate x here, we will divide both, 250. So cancel out 250 in this side, then 1,500 divided by 250, and that is 6. So the answer is 6 ml per hour. Now let's solve neuroscience. Now let's do neuroscience on YouTube.